notes that we talked about yesterday, a logarithmic function is an inverse of, sorry about that part. Well, I asked you this in the check-in form. What is the inverse of the logarithmic function? Good job, exponential. There we go. So this is a key idea from yesterday, that exploration I had you do. Exponential functions, its inverse is a logarithmic function. Likewise, a logarithmic function is the inverse of an exponential function. Log x, so log(x), is an abbreviation we use for logarithms. A logarithmic function has a vertical asymptote, and on the parent function, it's x equals 0. Now let's make a little note for ourselves. Recall, on an exponential function, it had a horizontal asymptote. So they're inverses. So we do need to remember that. Today we're going to focus on parent function graphs for logarithmic functions and their transformations. So I need you to have your graphing calculators out. Mr. Shore, if you can help me with the calculators. So if you have the TI Nspire, okay, well, I'll try and do this in groups. If you have the TI Nspire, do you see on, I'm going to borrow your filling. Okay, on the TI Nspire, if you go on the left column, do you see where that the 10 to the X button is? You see on the TI Nspire, on the bottom is beside the number 1. If you hit Control and that button, it's going to give you, I'm sorry, somehow I am on. I don't know how that happened. No. Okay. All right. So you hit the Control, and so what we're going to do in the table is I want log base 2 of 0. So you're going to put the 2 and then the 0, like that. Okay, anybody have the TI-84? Anybody else? Okay, so let me just show you on yours. What you're going to do is there's your log. Is the 0 in the parentheses? Yes. You should be getting an error. Okay, you should be getting an error. So you can now go down the log. Oh, and then okay, the first one is an error, and it should be because, so here, let me make sure we're doing this correctly. The base is 2, and that's a 0. We're going to say that's undefined. And doesn't that make sense? Because there's a vertical asymptote at x equals 0. Now, on your graphing calculators, now you're going to do log base 2 of 1. Okay, I'm so pleased to see all the graphing calculators. Awesome. So what's happening when you do log base 2, 1? 0. Good job. Then let's do log base 2 of 4. What are we getting? 2. So I'm going to do log base 2 of 8. What do you get? 3. And log base 2 of 16. Anybody got it? 4. All right, so here's the deal. On your graph, you're going to make a vertical asymptote of x equals 0. So we're going to put x equals 0, and we're going to draw that. Then I'm going to plot my points. The 1, 0, 4, 2, and 8, 3. Now what I would like you to do is I would like you, on your graphing calculators, on the TI Nspire, you know how to open a new document and open a graph. So hit doc, open a new doc, and click graph. Then what I would like you to do, let me see if I can pull mine up. See if I can multitask here. Application. All right, let's see if I can't show you at the same time. So what you should be able to do on the graph is pull up that log, put a base 2, and put an X inside. So I'm trying to get mine to come up so I can type it. It's chugging along. Ooh, I see it on some of the graphs. Okay, if you're getting it, share with people at your table. Not quite sure why this is taking so long. There we go. Okay, here it comes. So help each other, and if somebody doesn't have it, oh, good, it is coming. All right, cool. That's not the variable. That's like the and then you should be able to make a graph, and there it is. Okay? Okay. All right, so here we go. All right, so those of you, since most of you have the Nspires, here's what I was asking you to do. You go up to a graph, and so you're going to do Control 10 to the X. We're going to put a 2 in, and we're going to put the letter X and press Enter. So this is a fantastic looking graph. You see, here's our 1, 0, our 4, 2, our 8, 3. But do you notice this graph is getting closer and closer to the y-axis without touching it? So let me come back here, and even though our table didn't show it, it does get closer and closer to that x-axis. So my domain is 0 to infinity, and the range is -infinity to infinity. So here's the big idea, and we introduced this yesterday by starting with an exponential, and we switched the x and the y's. So the big idea here is the range The range of all logarithmic functions will be negative infinity to infinity. Let me say that again, because it's really important. The range of all logarithmic functions will be negative infinity to infinity. My domain, how will that domain get shifted when I start doing some transformations? Awesome, okay? If I shift it left or right, that's going to impact the domain. Up, down won't, because it's already going to infinity. So those are good things to think about. My x-intercept, where is this graph crossing the x-axis? 1, 0. There's no y-intercept. And then watch my end behavior. The end behavior is what's happening at the ends to the left and to the right. So look at this one. Notice it's not going to infinity. As x approaches 0, so as I come into 0, where does the red graph head? Negative infinity. Awesome! Awesome. That's going to negative infinity. And even though it's moving rather slowly, as I approach x's infinity on the right, where will it eventually go? It does go up to infinity. Pretty slowly. So now, if we want to look at a transformation, and I'm going to rewrite this just to make sure we're crystal clear on this. There's no parenthesis around the x minus 3. Let me say that again. There is no parenthesis around the x minus 3. So this really, if it helps, this is really saying y equals the log base 2 of x minus 3. What, based on what we know about left, right, up, down, stretch, shrink, flip. What? Awesome! Oh my gosh, you guys are on fire. This is down 3 units because it's on the outside. This is the beauty of the math that we've been doing with parabolas, with square roots, with absolute values, exponentials. It's all the same, okay? So, in this next part, if I'm looking at this one, what would be the mapping notation? Yes, you got it, Davy. So this is x comma y minus 3. So if it helps, I'm going to take the table from above. So 0 was undefined. We had, whoops. One, 0, 4, 2, 8, 3, and 16, 4. This was our parent function. So the parent function, let's maybe make sure we're clear. The parent function is the f of x equals log base 2 of x. Okay, so this is that parent. All right, so now let's use the mapping notation. The x values remain the same. We just write the x values in that column. And then what does y minus 3 tell us to do to the y values? Subtract 3 from each of those y values. So let me give you a head start. So I'm going to change colors. So undefined is still undefined. So then, Daniel, what did you put for the 1? If we're going to subtract 3, what do you get? Good job, negative 3. All right, then Charlie, what do you put for the 4 if we're going to move it down 3? Negative 1, you got it. All right, Keller, how about for 8? What was your new y value? 0. And Angelo, how about for 16? What's our new value? 1. All right, so the range is always negative infinity to infinity. I moved it down 3. So, Ellie, if I move it down 3, did that impact my domain? No, it didn't. So my domain remained 0 to infinity. Only the left-right affects the domain. The equation of the asymptote is the same, okay? My x-intercept. Ooh, look at your table. Do you see the point where it's crossing the x-axis? Not at 1, 8. Why is it 8? You're right, but why? Because the y is 0. That's on the x-axis where y is 0, okay? There's no y-intercept because I didn't move it left or right. How about the end behavior? So let's kind of make a rough sketch here. Here would be the original, and if I just move it down 3, it just moved it. I mean, that doesn't look very good. Let me erase that. That's not what it looks like. So it's literally down 3. So as x gets closer to 0, what does the y value do? Negative infinity. And as x approaches infinity, where does my y value go? It gets there, but it goes rather slowly. Note, moving vertically up and down does not change the position of the asymptote, and it does not change the domain. All right, questions on that? All right, the next one says graph the parent function y equals log base 3x. So here's what I want you to do. You have to do this on your calculators. Go type these in. Now, I really can't tell you why those are undefined yet. We're going to get there, but for now, we're just going to trust the calculator. No, you want to go to a blank calculator. Well, first we're going to do the tape. So what you want to do is, well, you could, if you want to, you could just put in a graph, you could put y equals log base 3x, and then you can go to menu and pull up the table. There's a way to pull up the table for all of them, but thing is, it's going to give you a whole bunch of numbers, and you might have to scroll a long time. I would just go to the calculator page and just type it in. I think that's because there's so few. All right, did you get 1, 0? Did you get 3, 1? What did you get for 9? 2? And how about 27? Is anybody noticing a little pattern here? There's something happening, okay. So this is a parent function, so my equation of the asymptote is going to be x equals 0. The domain is 0 to infinity. The range is negative infinity to infinity. All right, now I'm going to go ahead and just plot those first 3 points. And so I'm going to have the 1, 0, 3, 1, and 9, 2. And then if you graph it on your graphing calculators, it does shoot down to negative infinity as x is approaching the vertical asymptote. So the x-intercept is 1, 0. There's no y-intercept. Then as x approaches 0, it's going to negative infinity. And as x approaches infinity, y goes to infinity. All right, questions on this part? So let's look at a transformed function. Suppose I have y equals log base 3 of x minus 3. What transformation is this one? Awesome, right? 3. Then what's the mapping notation if I want to move all the points right 3? X plus 3, comma y. So go ahead and fill in the table with this mapping notation. Add 3 to your x values, but the y values stay the same. All right, so Zoe, what would be the first x value in my table if I move it right 3? 3, there you go. Abby, what would be the next x value? Say it again. So if I started with 3, what's the next x value? Okay, but you're supposed to fill in the table. Okay, you're supposed to fill in the table. All right, Jordan, what would be the next x value? 4, all right? Because you take your 1 and add 3 to it. All right, then Gabe, what's the next x value? 6, right? Because you had 3 and you're adding 3. All right, and then Andrew, what's the next x value? 12. All right, and then how about the last one? Bella? 30. Then I just take, I had undefined, 0, 1, 2, and 3. All right, the domain, okay, let's write ourselves a note. A left-right shift changes your vertical asymptote and domain. Let's write this down to help us out. A left-right shift changes the vertical asymptote and the domain. So what would be the equation of my vertical asymptote then instead of x equals 0? Yeah, Angelo? X equals 3. So I immediately then put my domain in, and my range for logarithmic functions is always negative infinity to infinity. In our table, we can tell the x-intercept. What's the x-intercept here? 4, 0. So there might be a y-intercept. No, if I moved it right, there's not. Okay, no, I'm further to the right. If I moved it left, I can get it to cross the y-axis. And right now, we don't have the tools to figure out how to do it besides graphically. So let's go back up to our graph, and let's plot this one. I'll come back to this in case you still need it. But let me come back here, and let me plot some of these. This was 4, 0. I had 6, 1. And let's say 12, 2 is a little bit off. I have a vertical asymptote now of x equals 3. So it would look like this. And again, I'm going to scroll back down so you can see the other pieces of information. But big idea, on a graph, you are required to draw the vertical asymptote, just like you did horizontal asymptotes with exponentials. Because that's our boundary. That's what it's getting closer and closer to. All right, everybody got the graph okay? All right, let me come back down here then. Then as x approaches 3, it was going down to negative infinity. And as x goes to infinity, it was going up. Note, moving horizontally, left or right, does change the position of the asymptote. It moves the number of units and in the direction of the horizontal translation. All right, that finishes the notes. So what I would like you to do is go ahead and pull up the homework.